Think math.
In middle school, sine and cosine were ratios of sides in a right triangle. A length over a length, so always positive. Yet in high school, the sine of an angle turns negative. How can a ratio of lengths possibly be negative? There was a frustrating restriction hiding in those ratios. The angle you measure a ratio from always sits between 0 and 90 degrees. So a ratio for 120 degrees cannot even be drawn. No such triangle exists. Without widening the definition, we stop right here. So we move the triangle into a circle of radius 1, the unit circle. Lay the hypotenuse along the radius and its length becomes 1. Then sine is the height over 1, which is just the height, and cosine is the base over 1, which is just the base. The division has vanished. Now the decisive step. That height and that base are really the coordinates of a point. The y-coordinate of the point at the end of the radius is the sine, and the x-coordinate is the cosine. What was a ratio of sides has been redefined as a coordinate. And this is where negatives come from. A length can never be negative, but a coordinate can. In the upper left, x is negative, so the cosine is negative. In the lower left, both are negative. And in the lower right, only y is negative. There is no sign chart to memorize. Picture the coordinate plane and you can simply read it off. To sum up, sine and cosine moved from a ratio of sides onto coordinates. Inside a right triangle, the ceiling was 90 degrees. But on the unit circle, you can turn either way as many times as you like. We widened the definition. Yet for acute angles, the old values hold exactly. A sip of math every day with Think Math.